Let's review this Unit 4 tank and tank test demo. Here we have a Java class named TankTest, and it's, for convenience, located on the same web page as a corresponding class called tank. The purpose of this client program above the red line is to test the tank class, which I just wrote, and to make sure its methods and everything works correctly. So let's trace this client program. First, we have a object variable being declared as a tank. So its data type is tank. And it's being initialized, or instantiated, I should say, in the memory of the computer. And we are calling the constructor that takes 3 parameters. Let's go check out that constructor. So down below here in the tank class, we do have a constructor that takes 3 parameters. We're ignoring the default constructor at this time because it's not being executed. And we have the parameters ammo, x, and y, which of course are filled in by the values 15, 50, and 50 in that one-to-one correspondence. The 15 plugs in for ammo, and 50s are plugged in for x and y. Well, the constructor here is simply assigning those 3 values into the underlying instance variables that they match up with. Well, those instance variables are all declared, if you notice closely, they're all being declared here at the bottom of the class, and they are all private, which we'll study later in this course, that instance variables, also known as properties, should usually be declared private. And they do have the data types int. Okay, well anyway, back up in the client program, Sherman, an object variable, now has 15 units of ammunition. Its position on some grid somewhere is x equals 50, and it's at the position y equals 50 as well. This chunk of code here simply prints out those underlying values that are being stored in Sherman. By concatenating here with the plus symbol, the nice little descriptive phrase ammo equals, I'm printing out that phrase ammo equals. Excuse my poor handwriting here, this is difficult to draw with the mouse. But this on the output screen, we'll see ammo equals, and that's being concatenated with whatever ammo is. Well, whatever my ammo is. We are calling an accessor method here with the object variable Sherman. So, to see that happen, we find the getAmmo method, which is a fairly typical accessor method. You typically have one accessor method for each of your properties. Since there are 3 properties in this class, there are 3 accessor methods, named with the prefix get for good style, and then the name of the accessor method is simply the name of the property, usually capitalized for good style. And the job of an accessor method is really just to return that underlying instance variable. So whatever number is currently stored in ammo, which I think was a 15, that number 15 is being returned back up to the client program where we called it, where we called getAmmo. So a 15 is now being plugged in here, and that's what appears on the output screen. It ends up saying ammo equals 15. And the same corresponding actions happen with the function, with the method calls getX and getY. I believe 50 and 50 will print out because of those 2 call statements. Oops, I'm sorry, right here, getX and getY, 50 and 50. Now let's trace this middle part of the client program. Well, the next 3 lines of code here, the next 3 statements, are all call statements for modifier methods. And for good style, a modifier method is typically a named set something. And the 15 that was stored in the object variable Sherman's myAmmo property is now being overwritten with a 20. The myX property, the property myX, and the property my y while we're at it, they are being overwritten with the values 60 and 70. Let's look closer at a modifier method like setX. The modifier methods are all conveniently placed in the same area of this class, and with a nice little comment statement noting that they're here. And the setX modifier method needs to accept a parameter, which I named x to sort of match up with the instance variable named myx. And because assignment statements work from right to left, whatever value was passed down to this parameter x, that value is then plugged in to myx, assigned to myx, and overwrites whatever old value was in myx. So the net effect is, within the client program here, the 50 that was stored in myx is now overwritten with the value 60. And we saw the same thing with the 20 and the 70 and those other two properties. Okay, here's an interesting method, shoot. It has no parameters. Well, let's scroll down to see what it does. The shoot method, it takes myAmmo and it subtracts 1. So the behind the scenes value that's stored in myAmmo is has 1 subtracted from it. And we could have wrote that code as myAmmo minus minus in Java, of course. So that's really a modifier method. We're modifying the amount of the value that's stored in the property myAmmo. And some people would call the shoot method a modifier method. Some people would call this moveTo method a modifier method because it does modify the properties myx and my. Even though it doesn't start with the prefix set, and neither does shoot, some people, the AP exam for example, could call these modifier methods. I don't. I just call modifier methods those methods who are typically prefixed with the word set and whose only job is to accept one parameter and to overwrite one instance variable with that new value that's passed to it. That's more classic modifier method in my opinion. Okay, well anyway, back up in the client program, the shoot method just occurs. Now this program doesn't do anything graphically, and a graphic interface is a whole nother level of complication that frankly we're not even going to get into this whole school year. The AP exam deals with underlying logic, the important stuff you could say, the underlying logic and what happens to the properties of an object rather than what it happens to look like on the screen and stuff that you would care about in like a modern game. The line of code here is Sherman.moveTo2030. We're calling the moveTo interesting method, and we're passing the two parameters 20 and 30. So they plug in for the formal parameter names new x and new y, and therefore a 20 overwrites the old value in myx, and the number 30 overwrites the value in my y. And that's just what that does. So picture, if you will, a tank that was at the position 50-50, and now I would guess that it's moved southwest to the position 20-30 on your typical XY coordinate system. Okay, the last interesting method here, display type. Again, there are no parameters here. And we scroll down. Oh, look, instead of Sherman.moveTo, this is called a little differently. Instead of the object variable in front of the dot, we have the name of the class tank in front of the dot. That means that display type is an example of a static method. These other methods up here, the modifiers, accessors, and interesting methods, they are called instance methods, which I usually just call methods. But they're called instance methods because they all specifically relate to one instance of the tank class. You see, an object variable named Sherman here is sometimes called an instance. And you can have as many instances of a class as you want. In other words, you can have as many variables that have the data type tank as you'd like. In this demo program, we only have one object variable to keep things simple. But eventually, of course, we'll have lots of tanks. And they all would have different names, but they would all have the data type tank. So this display type method is an example of a static method. It doesn't apply to just one tank. It applies to, you could say, the whole batch of tanks that exist at one time in a client program. Well, there is only one tank right now, but we still would say that display type applies to the whole tank class or the whole set of tanks. Let's scroll down and see what this display type method does. The display type method simply system out prints I am a tank. It displays an object's data type, or it displays just this data type wherever this display type method is called. Notice the word static here, and the word static did not appear in any of these other traditional instance methods. So when the word static appears in the header of a method, then you would only ever see it being called with the name of the class, which is always capitalized for good style, by the way. So that's another tip-off that display type is a static method here because you have a capital T. It would be bad style to have named Sherman with a capital S. Instance variables, even if they're proper nouns, should be typed with a lower case first letter. So the net effect is that I am a tank prints out because of that call statement. Okay, that's about it. The rest of this is just a review of what happened up here. In this test class, we are simply printing out the initial values of a tank, a newly constructed instantiated tank. And then we're doing stuff in an interesting way with that tank. And then we just print out in its state at the end. The state of an object, the state of Sherman here, is its set of properties and what their values are. So its initial state is printed out, stuff happens, and then its final state is printed out, its final status, or state, if you will. Hope this helps.